Hello everyone. Let's get started with today's session. I'm excited to welcome you all. Whether you're a student, a fresher, or a working professional, this training is designed to help you think like an industry developer, not just follow tutorials. We don't just learn concepts here. We focus on building real-world skills that truly matter in your career. I'm Bala, a software developer and corporate trainer with over 12 years of experience. Today, we'll explore how to develop the right mindset and skills to succeed in the industry. So, let's dive in and make this session a valuable step forward in your journey. Welcome to this overview of the upcoming topics. We'll start with the basics of Angular in Section 1, where I'll introduce the core concepts and architecture. Then, in Section 2, we'll get hands-on by building our first app in Angular, marking the practical beginning of our journey. Moving on to Section 3, we'll explore essential techniques like data binding, ngFor for rendering lists, style management, pipes for data transformation, and built-in directives that make development easier. In Section 4, we'll delve into modules and services, which are fundamental for organizing and sharing functionality across your app. Section 5 covers RxJS and how to perform REST API calls, enabling us to handle asynchronous data streams effectively. In Section 6, we'll focus on authentication and security, crucial for protecting our applications and user data. Section 7 introduces template-driven forms, a straightforward way to handle user input, while Section 8 covers reactive forms, offering more control and scalability. Moving to Section 9, we'll look at component communication, essential for building interactive and modular applications. This entire journey is designed to equip you with the skills needed for full-stack development, and I'll be guiding you through each step. And of course, a special shout-out to Bala, whose expertise will support us throughout this course. Now, let's take a closer look at some of the advanced topics we'll be covering in the upcoming sections. Starting with Section 10, debugging and auto-deployment. This is where we learn how to efficiently troubleshoot our applications and automate the deployment process to streamline our workflows. Moving on to Section 11, life cycle hooks. These are essential for understanding how components behave from creation to destruction, giving us control over their behavior at each stage. Then, in Section 12, pipes, deep dive. This is about transforming data in templates to make our UI more dynamic and user-friendly. In Section 13, directives, deep dive. Here we explore how to extend HTML with custom behavior, which is key for creating reusable modular components. Next, we have advanced routing in Section 14, where we delve into complex navigation strategies and lazy loading techniques to optimize our app's performance. Section 15 focuses on animations, adding life and polish to our interfaces, making them more engaging for users. Moving to Section 16, feature modules. These help us organize our app into manageable, scalable sections, improving maintainability. Section 17 covers dynamic components, an area that allows us to load and render components on the fly, giving our apps a high degree of flexibility. Finally, in Section 18, unit testing and Angular zones. This is about ensuring our code is reliable through testing, and understanding zones helps us manage change detection efficiently. Throughout this journey, Bala's expertise as a full-stack developer ties everything together, showing how these concepts fit into real-world development and best practices. Welcome to this part of the course, where we'll be diving into the fundamentals of Angular. First, we'll start with an introduction to Angular itself, understanding what makes it such a popular framework for building dynamic web applications. Then, I'll guide you on where to begin practically, so you can start experimenting and building right away. We'll also discuss the main goals of Angular to give you a clear sense of what it aims to achieve. Next, I'll explain the code compilation process in Angular, helping you understand what happens behind the scenes when you write your code. We'll go over some do's and don'ts to keep your Angular projects efficient, maintainable, and error-free. Then, we'll explore the building blocks of Angular, those fundamental pieces that form the foundation of any Angular app. We'll look into Angular's architecture, which ties everything together, providing a solid structure for your projects. Additionally, I'll give you an overview of Angular's packages, showing you how different modules and libraries work together. We'll also review the folder structure of an Angular project, so you know where everything belongs. Finally, we'll revisit the basics of Angular, making sure you understand the core concepts before moving forward. All these points are interconnected and set the stage for your journey into mastering Angular. So, let's get started with understanding what Angular is all about and how it can empower you as a developer. Let's take a closer look at our course roadmap. We'll start with an introduction to Angular, which is essential for understanding the framework's core concepts. Then, we'll move on to setting up the development environment, ensuring you have everything ready to start coding seamlessly. Next, we'll do a TypeScript crash course, since Angular heavily relies on TypeScript, and mastering it will make your development smoother. After that, we'll dive into a complete Angular course, covering all the fundamental features and best practices. Once you're comfortable with Angular, we'll build a real-time e-commerce app, giving you hands-on experience with a practical project. Following that, we'll focus on creating the front end with Angular, designing an engaging and functional user interface. We'll also develop the back end using Spring, which is a powerful Java framework, to connect your front end with a robust server-side logic. Throughout this course, you'll see how each piece connects to form a full-stack application. Finally, we'll go through the course roadmap, so you understand the journey ahead and how each step builds on the previous ones to make you a proficient full-stack developer. This structured approach is designed to help you gain both theoretical knowledge and practical skills. Let's talk about one of the most popular front-end frameworks for creating maintainable web applications today. It's actually a complete rewrite of AngularJS, which many of you might be familiar with. Developed by Google, this framework has gained a lot of traction because of its robustness and flexibility. One of the key tools that makes development faster and more efficient is the Angular CLI. It helps you generate components, services, and other parts of your application quickly, streamlining the development process. Now, you might be wondering, what exactly is Angular? Well, it's a platform and framework for building dynamic web applications. It provides a structured way to develop scalable and maintainable code. Throughout this presentation, we'll see how Angular fits into the bigger picture of modern web development and why it's become such a crucial tool for developers around the world. Let's take a closer look at the features of Angular and how it organizes different parts of an application. When we talk about business logic, this is typically written in services. These services handle data processing, communication with APIs, and other core functions that drive the app's behavior. Moving on to design logic, this is written directly in the template, which means the HTML and Angular directives work together to define how the UI looks and behaves. For application logic, this is managed within the component, where we handle user interactions, data binding, and component-specific behavior. Finally, application state is stored in the component itself, keeping track of data that changes over time and affects what the user sees. By understanding how these pieces fit together, you can better organize your Angular applications for clarity and efficiency, which is essential as we build scalable, maintainable web apps. Now, let's talk about making our code maintainable. When we write maintainable code, it becomes much easier to update and improve our application over time without introducing bugs. This also helps new team members get up to speed quickly. One way to achieve this is by simplifying our development process for single-page applications. When the code is easier to develop, it naturally becomes easier to manage and extend. Additionally, making our code unit testable is crucial. By writing modular, isolated pieces of code, we can test each part individually, which helps catch errors early and ensures the overall stability of our application. To support this, Angular encourages a clear separation of concerns. We want to separate business logic from application logic, so core calculations or data handling are not tangled with UI code. Similarly, separating HTML logic from application logic allows us to keep our templates simple and focused on presentation, without mixing in complex code. And finally, separating DOM manipulation logic from application logic means that our code is cleaner and more predictable. Instead of directly changing the DOM everywhere, Angular handles updates efficiently, which improves performance and makes our code more maintainable. All these goals, making code maintainable, easier development, and testability, are interconnected. They help us build robust, scalable, and manageable applications with Angular, ultimately supporting our overall goal of creating high-quality, user-friendly web applications. All right, let's take a closer look at this slide. Here, we see the flow starting with the source code, which is written in Angular. This is what developers work with directly. Next, that source code gets processed through the Angular compiler. This step is crucial because it transforms our high-level Angular code into a format that browsers can understand. Now, once the Angular compiler has done its job, it generates an application template, which essentially is the structure and layout of our app. This template, combined with the source code, is then handled by the TypeScript compiler. The TypeScript compiler converts our TypeScript code into JavaScript, which browsers natively understand. And speaking of the browser, when it finally executes our code, it runs the JavaScript, bringing our application to life. So in summary, this flow illustrates how Angular code is transformed step by step, starting from developer-friendly source code through compilation stages, until it becomes executable JavaScript that runs smoothly in the browser. This process is fundamental to understanding how Angular delivers dynamic, client-side applications efficiently. Let's talk about some essential best practices in Angular development. First, always make sure to use routing and modules. This helps keep your application organized and scalable. When it comes to security, prefer routing guards and JWT for authentication and access control, ensuring your app remains secure. It's important to manipulate application data by writing your business logic inside components, but always keep your REST API calls and business logic encapsulated within services. Remember, services should return observables, which makes handling asynchronous data more manageable. For styling, always include a global styles CSS file for universal styles and local component-specific styles in their own component CSS files. To keep your styles maintainable and powerful, use a CSS preprocessor like SCSS. When designing your UI, prefer using Bootstrap or an equivalent framework to speed up development and maintain consistency. Also, always write your CSS with a preprocessor like SCSS to take advantage of variables, nesting, and mixins. Never perform DOM manipulation directly within Angular components. This keeps your application logic independent of the visual layer, making your code easier to test and maintain. Similarly, avoid writing JavaScript directly in your templates, as this can lead to messy and hard-to-maintain code. Business logic should never live in your components. Keep it in services to promote separation of concerns. Also, avoid using jQuery for DOM manipulation, as Angular provides its own tools for that, and mixing them can cause conflicts. By following these do's and avoiding these don'ts, you'll create a more robust, maintainable, and secure Angular application that aligns well with best practices and scalable architecture. All right, let's take a closer look at the building blocks of Angular. First, we have dependency injection. This is a powerful pattern that allows us to load service objects into our components easily, promoting modularity and making our code more testable. Next is data binding, which acts as a mediator between our components and templates. It keeps our UI in sync with the underlying data, making updates seamless. Then, we have modules, which are essentially collections of components. They organize our application into manageable sections, helping us maintain clarity as our app grows. Moving on, directives are used for direct DOM manipulation. They let us modify the structure or appearance of our elements dynamically, adding interactivity and customization. Services handle the business logic and REST API calls. They keep our data operations separate from the UI, ensuring a clean architecture. Templates define the visual design and layout of our app, connecting the logic with the user interface. Finally, components serve as the core building blocks. They contain the app data and handle events, tying everything together into a cohesive application. These elements work together to form the fundamental structure of Angular, making it a powerful framework for building dynamic web applications. Let's dive into some core concepts of Angular architecture. First up, dependency injection. This is a powerful pattern that allows us to manage how components and services are created and how they interact. It helps us write more modular, testable, and maintainable code. Next, we see metadata. In Angular, metadata is used to decorate classes so that Angular knows how to process them. It provides additional information about components, directives, or services, guiding Angular on how to handle these elements within the application. Then there's data binding, which is a fundamental feature that connects your application's data to the user interface. It's what makes your app dynamic and interactive, automatically updating the view when the data changes. We see it mentioned twice here, emphasizing its importance. It's a key part of how Angular keeps the UI and data in sync seamlessly. Moving on, Angular architecture is all about the structure of an Angular app. It's composed of different building blocks like modules, components, services, and more, all working together to create a cohesive application. Speaking of modules, they are the organizational units in Angular. They help compartmentalize your app into functional parts, making it easier to manage, lazy load, and scale. Connecting all these points, understanding dependency injection, metadata, data binding, and modules helps us grasp how Angular's architecture is designed for efficiency and flexibility. This foundation allows us to build complex, robust applications with a clear, maintainable structure. Let's take a closer look at how Angular initializes and runs an application. First, Angular invokes the Angular compiler, which is responsible for JIT, or just-in-time compilation. This process compiles your templates, which are essentially your HTML code, into JavaScript that the browser can understand and execute. It also specifies the startup module, which is the entry point of your application, and then begins executing the application itself. Next, we have the @Angular Platform Browser Dynamic package. This package plays a crucial role because it handles the compilation of your templates into JavaScript. Without this, Angular wouldn't be able to interpret the HTML templates and turn them into executable code. Moving on, the @Angular compiler package provides the essential tools needed for this compilation process. It offers built-in directives that are incredibly useful for building dynamic, real-time applications. For example, directives like ngIf, ngSwitch, ngClass, and ngFor help us control what gets displayed, how elements are styled, and how lists are rendered, all dynamically based on your application's state. Finally, the @Angular common package provides the core decorators, classes, interfaces, and modules necessary to run any Angular application. Think of decorators like @Component, @ngModule, @Pipe, and @Directive. They help define how your components and modules behave. Other tools like @Inject, @Injectable, ngZone, and lifecycle hooks like onChanges and onInit are also part of this package. These are fundamental building blocks that enable Angular to function smoothly and efficiently. So, in summary, Angular's startup process involves invoking the compiler, compiling templates into JavaScript, and utilizing these core packages to create a dynamic, responsive application. Each of these packages plays a vital role in making Angular powerful and flexible for building modern web apps. Now, let's look at some of the key Angular packages that form the foundation of building Angular applications. First, we have the Angular Animations package, which is essential for creating dynamic and engaging animations within your app. It provides predefined classes like Browser Animations Module, Animate, State, Style, and Transition, which help you easily implement complex animations without starting from scratch. These tools are crucial for enhancing user experience and making your app feel more interactive. Next, there's the Angular Router package. This one is all about navigation, handling how users move between different views or pages in your application. It includes classes like Router Module, Routes, Activated Route, CanActivate, and RouterLink. These help you set up and control routing logic, ensuring smooth transitions and access control across your app's various parts. Then we have the Angular Forms package. This is the go-to for managing user input and form validation. It provides classes like Forms Module, Reactive Forms Module, Validators, ngModel, and ngForm. These tools make it straightforward to create forms that are both user-friendly and robust, with built-in validation and dynamic form controls. Finally, there's the Platform Browser package, which includes the browser module. This package is fundamental because it contains the core services necessary for running your application in a web browser. It sets up the environment needed for everything else to function properly. In essence, these packages, Angular animations, routing, forms, and platform browser, are the building blocks that support the core functionalities of an Angular application. They enable you to add rich features, manage navigation, handle user input, and ensure your app runs smoothly in the browser. Now let's look at server-side rendering. Essentially, it allows your application to run on a server rather than directly in the client's browser. This can improve performance and SEO, especially for initial load times. Moving on, we have SSR, which provides the necessary predefined classes to handle change detection processes within an Angular app. This means Angular can efficiently track and update the view when data changes. Next is Zone.js, which supplies predefined classes for creating observables. These are vital for handling asynchronous data, such as responses from REST API calls or AJAX requests. Examples include observable, observer, and subject. Finally, we have Rx.js, which offers the essential commands to create, compile, build, and manage items within Angular applications. Commands like ngnew, ngserve, ngbuild, and ngtest are part of this, enabling smooth development workflows. All these packages work together to support and streamline your Angular development experience. Now let's take a closer look at the Angular file folder structure. As you can see, we have a variety of folders and files that make up our project. Starting with the etui folder, which contains our end-to-end test cases. These are crucial for testing the entire application flow from start to finish. Next, the src folder holds all the source code of the application itself. Inside src, you'll find the app folder, which is the core of our application. Within the app folder, there are several important files. The app component, SCSS, which manages the CSS styles for our main component, the app component, HTML, which contains the HTML templates, the app component, spec.ts, where we define our unit tests for the component, and the app component ts, which is where the main logic for the component resides. Moving further, we see app module, ts, which defines the module that ties everything together, and app routing, module, ts, responsible for setting up our navigation and routing configuration. Outside the app folder, the assets folder holds static files like images, icons, and other media. For example, favicon. Ico is the icon that appears in the browser tab, and index. HTML is our default startup page. Other key files include main.ts, which bootstraps the application, polyfills, ts, ensuring compatibility across different browsers by loading necessary scripts, style, SCSS for global styling across the entire app, and configuration files like Angular, JSON, package, JSON, and tsconfig, JSON, which manage project settings, dependencies, and TypeScript configurations. Overall, this structure is designed to keep our project organized, making it easier to develop, maintain, and scale as needed. It aligns with our goal of building a robust, modular Angular application. All right, now that we've set up the basics, let's move on to creating our first app in Angular. First, we'll add Bootstrap, which is a powerful CSS framework that helps us build responsive and visually appealing interfaces quickly. Once Bootstrap is integrated, we'll set up a navigation bar using Bootstrap's navbar component, making our app easy to navigate. Next, we'll create and nest components, which are the building blocks of Angular applications, allowing us to organize our code efficiently and reuse elements. After that, we'll implement basic routing, enabling our app to load different views based on the URL, which is essential for creating a single-page application experience. Remember, each of these steps is a fundamental part of building a functional and scalable Angular app, tying everything together as we move forward in our development journey. Now let's look at how to specify the port number in the ngServe command. You can do this in a couple of ways. First, you can use the shorthand PT5200, which is quick and easy. Alternatively, you can use the longer form port 5200 or port equals 5200. Both are correct and clear. When choosing between these options, remember that both the long and short forms are valid, but consistency is key. For example, both port 5200 and port equals 5200 will work the same way. The most important thing here is understanding that either of these options tells Angular to serve your application on port 5200 instead of the default port. This flexibility allows you to customize your development environment as needed. So when you're running ngServe, just pick the option that fits your style or project requirements. And remember, both B and C, using port 5200 or port equals 5200, are correct choices for specifying the port number. Next, let's talk about the default location of the global CSS file named styles, SCSS, in an Angular application. The correct path is typically src/styles, SCSS. This is because Angular projects usually have a src folder where the main source files reside, and styles, SCSS, is generally placed directly inside this folder. The other options like app/styles, SCSS, or app/src/styles, SCSS, are less common unless you've customized your project structure. It's important to know the default because it helps you locate or modify your global styles easily. When you want to add or change global styles, you usually go straight to src/styles, SCSS, and Angular will include it automatically when building your app. Finally, let's review which tag is used for the navigation bar in Bootstrap within an Angular app. The correct tag is the nav tag. This is a semantic HTML element specifically designed for navigation purposes. Bootstrap styles this nav element to create a navigation bar that is both accessible and visually appealing. The other options like navigation or menu are not standard HTML tags for navigation. Using nav is best practice because it clearly indicates the purpose of that section of your page, making your code more understandable and accessible. So, whenever you're building a navigation bar in Bootstrap with Angular, remember to use nav to ensure your site is both functional and semantically correct. Alright, so for this assignment, we're going to focus on creating a simple wizard using Angular routing. The main idea here is to build a set of components that represent different steps in the wizard, and then set up navigation between them. Think of each component as a page or a step in a process. The key is to connect these components with Angular routing so that the user can move forward and backward through the steps easily. We'll add navigation buttons like next and back, and these will control the routing, allowing seamless movement between components. This approach not only makes our wizard modular and easy to manage, but also demonstrates how routing can be leveraged for multi-step forms or processes. Connecting this to the overall theme, it showcases how Angular routing isn't just for simple navigation, but can be a powerful tool to create guided, step-by-step user experiences. It's a fundamental concept that helps us build more interactive and user-friendly applications. Alright, so in this part of the project, our task was to create several key components for the wizard. We built the personal details component, contacts details component, skills component, and work experience component. Each of these handles a specific section of the form, helping us organize the data collection process. Additionally, we developed the wizard finished component, which serves as the final step, signaling the end of the wizard process. The crucial part here is enabling smooth navigation between these sections, and for that, we used router links. This allows us to move forward and backward seamlessly through the wizard steps. The main focus is on creating a user-friendly, step-by-step flow that guides the user through each part of the form without confusion. By integrating routing this way, we make the wizard modular, scalable, and easier to manage. Connecting this to the overall theme, building this wizard with routing not only improves user experience, but also demonstrates the power of Angular's routing capabilities in creating complex, multi-step forms. It's a practical example of how well-structured routing enhances our application's functionality. Let's take a closer look at the component class. Essentially, this is where the core programming logic of our application resides. Think of it as the brain that manages how everything works behind the scenes. The component class contains properties, which are the data points or variables that store information, and methods, which are the functions or actions that can be performed. It's important to understand that the component class holds both the application data and the event handler methods. This means it not only stores the information needed for the app to function, but also defines how the app responds to user interactions or other events. Another key point is that the component class is responsible for supplying data to the template. In other words, it acts as the source of all the information that gets displayed on the screen. Without this class, the template wouldn't know what to show or how to behave. So, in summary, the component class is the central piece that ties together data, logic, and user interaction, making it essential for building dynamic and responsive applications. All right, let's take a closer look at this slide. Here, we're exploring the component hierarchy within our application. Starting from the top, we have the root component, which acts as the foundation of our structure. Beneath that, we see the root component again, emphasizing its central role. Moving down, we encounter the template and component, which serve as the building blocks for organizing our UI. Focusing on the nested elements, notice how the grandchild is a further extension of the child component. This illustrates how components can be nested within each other, creating a hierarchy that reflects the UI's structure. For example, the grandchild contains its own template and component, just like the child. This pattern repeats itself, showing a clear, consistent way to structure complex interfaces. The links, like http://localhost 4200/ represent where these components are rendered in the application. Understanding this hierarchy is crucial because it helps us manage how data flows through the app and how each component interacts with others. Recognizing the nested structure allows us to design more maintainable and scalable applications. This slide encapsulates the core idea that components are the building blocks, and their relationships define the overall architecture. Let's take a closer look at the template section. This part defines the structure of our component using HTML-like tags. It provides the skeleton that our component will render on the page. Moving on, we see the style sheet details, which specify the CSS rules applied to this component. The style is scoped to ensure it affects only this component, helping us keep styles organized and avoiding conflicts. Next, we have the component itself, represented by the class appComponent. This class contains properties, which hold the data or state for our component, and methods, which define the behavior or actions that our component can perform. Then there's the metadata associated with the component. The decorator, marked with @component, links everything together. It specifies the template URL, which points to the HTML file for the component's view, and the selector, which is the custom tag name used to include this component in other templates. It also links to the style URLs, ensuring the correct styles are applied. This entire setup is crucial because it encapsulates all the necessary information to define a reusable and maintainable component in Angular. It highlights how Angular promotes modular design by combining templates, styles, and logic into a cohesive unit. Understanding this structure is key to building scalable applications. Let's take a closer look at the relationship between the template's HTML element and the component's property. Essentially, the value in the template's HTML element will automatically be reflected in the component's property, and changes in the component's property will update the template's HTML element as well. This creates a dynamic, two-way connection that keeps both in sync seamlessly. This synchronization is what we call two-way binding, which is a core concept in Angular for managing data flow between the view and the component. Now, there are different ways this can happen, like event binding, property binding, and interpolation binding. Each method serves a specific purpose in how data moves between the component and the template. In essence, this relationship highlights the power of Angular's data binding system, enabling us to create interactive and responsive user interfaces where the view and the data model are always aligned. This is fundamental to building efficient, dynamic applications. All right, let's take a closer look at data binding, which is a core concept in Angular. On this slide, we see examples like style property and ngClass being bound to values. The key point here is that we can dynamically set styles and CSS classes based on conditions or data in our component. For instance, when we see style property equals value, it means we're directly assigning a style value. But more interestingly, we often use a ternary operator, like style property equals, condition, true value, false value. This allows us to change styles dynamically depending on whether a condition is true or false. Similarly, with ngClass, which is Angular's directive for class binding, we can bind classes conditionally. For example, ngClass equals condition. True value, false value means that a class will be applied only if the condition evaluates to true, giving us flexibility to toggle classes based on our application's state. Connecting this to our overall theme, these data binding techniques help us create more interactive and responsive UIs. They make it easier to control styles and classes dynamically, rather than hard-coding everything, which leads to cleaner and more maintainable code. So, understanding these bindings is essential for building dynamic Angular applications that respond seamlessly to user interactions and data changes. All right, let's take a closer look at ngIf and else in Angular. When you want to conditionally display content, ngIf is your go-to directive. You can use it in a simple way like this by just adding *ngIf equals condition to your element. If the condition is true, the element will be rendered. If false, it will be removed from the DOM. But there's a more advanced way to handle this, especially when you want to show different templates based on the condition. That's where the syntax with then and else comes in. You can specify a template to display if the condition is true and another one if it's false. It looks like this: ngIf equals condition, then true template, else false template. This approach gives you more flexibility and helps you manage complex conditional rendering more cleanly. Remember, the simple version is great for straightforward cases, but when your UI logic gets a bit more involved, the then-else syntax becomes very handy. Understanding these different ways to use ngIf really helps you control what your users see, making your applications more dynamic and responsive to various states. Keep this in mind as we continue exploring Angular's powerful templating capabilities. Now, let's take a closer look at some of the built-in pipes we can use in Angular to transform data within our templates. First up, we have the uppercase pipe, which converts any string to all uppercase letters, making it great for emphasizing or standardizing text. Conversely, the lowercase pipe turns strings into lowercase, which can be useful for consistency or formatting purposes. Next, there's the slice pipe. This one allows us to extract a specific part of a string, based on start and end indices, giving us control over which portion of the text we want to display. Moving on, the number pipe with the .2 format controls how many decimal places are shown and adds digit grouping, making numbers easier to read, especially with large figures. Then we have the currency pipe, which adds a currency symbol, such as USD, seamlessly formatting numbers as monetary values. The percent pipe is straightforward. It converts a number into a percentage, which is handy for displaying ratios or proportions. We also have the JSON pipe, which converts JavaScript objects into a JSON string, making complex data structures easier to visualize during debugging or display. Lastly, the date pipe allows us to specify a date format, giving us flexibility in how dates are presented, whether that's just the year, month, and day, or even a full timestamp. All these pipes are built into Angular and serve as powerful tools to dynamically manipulate and display data, ensuring our templates are both functional and user-friendly. Let's take a closer look at some examples of date formats using the date pipe. Starting with the date and time representations, at the top we see a specific timestamp, 201/12/31 at 11:59:59 p.m., which is the last moment of December 31st, 2019. The O indicates whether it's AM or PM, and here we see it's PM. The 24-hour format, HM, shows 23:59, which is just before midnight. Next, we have day names with EEE representing the abbreviated weekday, which is Tuesday, and EEE giving us the full name Tuesday. Similarly, for months, MMM shows DEC, short for December, and MMMM spells out December completely. The time zone offset is +0530, indicating the time zone difference from UTC. Moving to the date formats, the short date style displays as 31/12/2019. The medium date expands slightly to DEC 31, 2019, and the long date is shown as December 32, 2019, which seems to be a typo. It should be December 31, 2019. The full date provides the complete weekday, month, day, and year. Monday, December 31, 2019. For time, short time shows 11:59 a.m., medium time is more precise with 11:59:59 a.m. Combining date and time, we have formats like short, which displays as 31/12/2019, 11:59 a.m., and medium, which gives us DEC 31, 2019, 11:59:59 a.m. Lastly, we see alternative date formats such as DMY, which again is 31/12/2019, emphasizing the flexibility of the date pipe in formatting dates according to different regional preferences or requirements. Understanding these formats helps us present date and time data clearly and consistently in our applications. Let's walk through these Angular lifecycle hooks to understand how they fit into the overall component behavior. First up is ngOnChanges. This method is called whenever a data-bound property changes, making it essential for reacting to input changes dynamically. Next is which runs once after the component's data-bound properties are initialized. It's like your setup phase. Then we have ngDoCheck, which is more advanced. It allows you to detect and respond to changes Angular might not automatically catch, giving you greater control. Moving on, ngAfterContent, and it occurs after Angular projects external content into your component, so it's perfect for initializing content that comes from outside. Following that, ngAfterContentChecked runs after Angular checks the projected content, useful for responding to any updates. Then there's ngAfterViewInit, which is called once Angular has finished initializing your component's view and its child views. Think of it as the point where your component's visual tree is fully set up. After that, ngAfterViewChecked runs after Angular checks the component's views, helping you respond to any changes detected. We also have ngOnDestroy, which is the cleanup phase, called just before Angular destroys the component or directive. Think of it as your chance to release resources or unsubscribe. It's important to see how these hooks connect in the lifecycle, starting from the constructor, which sets up initial variables, then ngOnChanges when inputs change, for initial setup, and then the various after, and doCheck hooks that monitor changes. Finally, ngOnDestroy ensures everything is cleaned up properly. Understanding these hooks helps us build more predictable, efficient Angular applications by aligning our logic with the component lifecycle. Let's take a closer look at this example of an Angular component class, app. Here, we see it implements the onInit interface, which is key for setting up initialization logic. The constructor method is called first, before any Angular lifecycle hooks, and it's typically used for dependency injection or simple setup tasks. However, it's important to note that at this point, the component's inputs are not yet available. Then we have the method. This lifecycle hook is called after the constructor, and crucially, it's invoked after the first ngOnChanges. That means any input properties have been bound, and you can safely perform initialization that depends on those inputs here. Connecting this to our overall theme, Understanding when these methods run helps us manage component setup effectively. It clarifies when we should initialize data or set up subscriptions, ensuring our components behave predictably and efficiently throughout their lifecycle. Let's talk about Angular's modules, starting with the basics. Modules are essentially collections of components, directives, and pipes. Think of them as organized containers that group related pieces of your application together. Now, what is the main purpose of these modules? Well, they help us organize our code in a logical way, making our applications easier to manage and scale. The goals of modules are quite straightforward. First, they consolidate components, directives, and pipes into a cohesive unit that represents a specific functionality or feature. This way, everything related to a feature stays together, making development cleaner and more modular. Second, modules can make some of their components, directives, or pipes public. That means other modules can access and use them in their component templates, fostering reusability across your app. Third, modules enable you to import components, directives, and pipes from other modules that you need for your current module's components. This is essential for building complex applications with shared features. Lastly, modules can also provide services that other components can utilize. This centralizes shared logic and helps maintain consistency across your application. So, in essence, Angular modules are about organizing your code efficiently, promoting reuse, and ensuring that different parts of your app can communicate and share functionality smoothly. Let's take a closer look at Angular's modules, which are called ng modules. An ng module is essentially a class that's decorated with the ng module decorator, and this decorator contains important metadata that defines how the module functions. In this metadata, you'll find several key properties. First, declarations. These are the components, directives, and pipes that belong to this module. Think of them as the building blocks that are part of this specific module. Next is exports. This list includes the components, directives, and pipes that you want to make public, so they can be accessible in other modules that import this one. It's like sharing your tools with others. Then there are imports. These are other modules that your current module depends on. By importing them, your module can use the components, directives, and pipes that those modules have exported. Finally, providers. This is where you specify services that your components, directives, and pipes can use. These services are available throughout the module, enabling dependency injection and shared functionality. Connecting all of this to the bigger picture, ng modules help us organize our code into cohesive blocks, making our applications more maintainable and scalable. They define what is internal, what is shared, and what dependencies are needed, which is fundamental to building efficient Angular apps. Now, let's take a closer look at ngSwitch. This directive is really useful when we want to conditionally display different content based on a specific property. Think of it as a way to manage multiple options in a clean and organized manner. In the syntax, we start with a tag that has the ngSwitch attribute, which binds to a property, in this case, property. This property determines which case will be active. Inside, we have multiple tags with the asterisk ngSwitch case directive, each associated with a different value like value 1, value 2, or value 3. When the property's value matches one of these, the corresponding content is displayed. And if none of the cases match, we use ngSwitch default to specify what should be shown by default. This setup is particularly powerful because it allows us to handle multiple conditions elegantly, without cluttering our templates with complex if-else statements. Remember, ngSwitch helps us keep our code clean and our UI reactive to different states, which is crucial for building dynamic, user-friendly applications. Let's take a closer look at what a service is in Angular. Essentially, a service is a class that acts as a container for properties and methods. These methods mainly contain reusable programming logic, often referred to as business logic, and they also handle interaction with data sources. The key idea here is that services are designed to be accessible across different components. This promotes code reusability, and keeps our components clean and focused on their primary role, displaying data and responding to user actions like clicks. The main goals of using a service are to separate the business logic and data access logic from the component itself. By doing this, components only need to handle supplying data to the template and managing user interactions, while the service takes care of the underlying logic and data retrieval. Think of it this way: a service is a class which typically has properties and methods. It encapsulates the behind-the-scenes work, so components don't have to worry about how data is fetched or processed. They just call the service when needed. So, in Angular, a service is a fundamental building block that helps us organize our code better, making it more maintainable and scalable. All right, let's talk about creating a service class in Angular. First, you want to create a class that contains both your business logic and data access logic. This class will have properties and methods that handle specific tasks related to your application. Once you've got that, the next step is to prepare this service for dependency injection. To do this, you add the @injectable decorator above your service class. Now, to make the service available throughout your app or within a specific module, you can provide it globally by adding the provided root option inside the @injectable decorator. Alternatively, you can also provide the service locally by adding it to the providers array in your app module, or any other module or component where you need it. Once your service is set up for injection, the next step is to inject it into your component. You do this by adding a private reference variable of your service type in the constructor, usually with the @inject service decorator, or simply by declaring it as private in the constructor parameters. In practice, your component's constructor will look something like this: constructor, private service, service. This way, Angular takes care of providing an instance of your service whenever the component is created. To summarize, creating a service class involves defining a class with properties and methods, decorating it with @injectable with the appropriate provided or provider's configuration, and then injecting it into your components via the constructor. These steps are essential for managing your application's business logic efficiently and promoting code reusability through Angular's dependency injection system. Let's talk about notifications, observer, and observable. These are key concepts in a pattern often called message passing, where a publisher sends messages to subscribers. Think of the observable as the source that emits these messages and the observer as the recipient that listens in. The flow of how this works is quite straightforward. First, an observable is created. Then, an observer subscribes to this observable, signaling that it wants to receive updates. Once subscribed, the observable can pass messages. These are the notifications to the observer. Every time a new notification is sent, the observer receives it in real time. Now, where do we see this in action? Well, for example, when you're waiting for a response from an AJAX call or an API, the observable can notify you once the data is ready. Similarly, when performing large tasks in the browser, observables help manage updates efficiently. One important thing to remember is that observables only execute when an observer subscribes. If there's no subscription, nothing happens. This makes the pattern both powerful and efficient because it's reactive and only runs when needed. So, in summary, an observable is a data source that can emit messages, and an observer is a listener that reacts to those messages. This pattern is fundamental for handling asynchronous data flows and real-time updates in modern applications. So let's break down how the observable and observer work together. Imagine the observable as the source that emits data or events, like user inputs, HTTP requests, or custom data sources. It's essentially the producer. On the other hand, the observer is the entity that listens and reacts to these emissions. When the observable has new data, it sends it to the observer through the handle data method. If something goes wrong, like an error occurs, say, a network issue, the observable will trigger the handle error callback, allowing us to handle the problem gracefully. Once the data has been processed or consumed, the observable signals that the task is complete via the handle completion method. This lets us know that no more data will be emitted. The key here is understanding that this setup creates a push-based system where the observable pushes data to the observer, making the process reactive and efficient. This pattern is fundamental in managing asynchronous operations and streamlining data flow within our applications. Let's talk about what an Angular module really is. Think of a module as a container that holds different building blocks like components, directives, and pipes. These are the core pieces that make up your application's functionality. Modules help you organize these pieces logically, grouping related features together. The main goal here is to create a cohesive unit of functionality, so consolidating components, directives, and pipes that work together. Another important point is that modules can control visibility. You can make certain components, directives, or pipes public, meaning they can be used outside of the module, like in other parts of your app. Importing is also key. If a component in your module needs a directive or pipe from another module, you bring it in through imports. This way, you can reuse code efficiently across your application. And finally, modules can also provide services. These are like utilities or helpers that other modules can tap into, ensuring your app's functionality is consistent and maintainable. Overall, Angular modules are the backbone that keeps everything organized, reusable, and scalable, fitting into the bigger picture of building well-structured applications. All right, let's dive into this slide. Here, we see the pipe function with the map operator inside. This is part of RxJS, which is all about handling streams of data asynchronously. The map operator takes a function. Here, it's a simple function that receives data and returns that same data. Essentially, it's a way to transform or modify the data as it flows through the stream. Think of it as a way to handle the response from the server, taking that data, maybe modifying it, and then passing it along. On the right, you see the flow labeled handle data, which corresponds to receiving the modified response after the map operation. Once the data is handled, we subscribe to the observable, which means we're saying, "Hey, I want to listen for this data," and then we send the response back. Finally, the server is on the other end, providing the data, which gets processed through this pipeline. The key concept here is how the map operator allows us to process server responses smoothly within the reactive stream, making our data handling more flexible and efficient. This ties into the overall theme of reactive programming, building a flow where data is processed, transformed, and handled seamlessly from server to application. Today, I want to talk about authentication with ASP.NET Core. This is a fundamental aspect of building secure web applications. When we talk about authentication, we're essentially discussing how to verify the identity of users trying to access our system. ASP.NET Core provides a flexible and powerful framework for implementing this. It supports various authentication methods, including cookie-based authentication, JWT tokens, and external providers like Google or Facebook. One of the key advantages is that it integrates seamlessly with ASP.NET Identity, which simplifies user management and role assignments. By implementing proper authentication, we ensure that only authorized users can access sensitive data and functionality. Throughout this presentation, we've emphasized the importance of security, and authentication is a core piece of that puzzle. So, mastering how ASP.NET Core handles authentication helps us build safer, more reliable applications. In this slide, I want to walk you through the key components of our project structure that underpin the application's core functionality. First, we have the model's \project CS file, which defines the model class for the project table. This class essentially represents the data structure for projects within our database, allowing us to work with project data seamlessly throughout the application. Next, we see the view model's \login view model, CS, which provides the model class for the login view. This view model is crucial because it handles the data exchange between the login view and our backend, ensuring user credentials are managed securely and efficiently. Moving into the service layer, we have the service contracts \a user service, CS, which is an interface for the user service. Defining this contract allows us to implement different user-related functionalities consistently and makes our code more flexible and testable. Following that, there's services/user service, CS, which is the concrete implementation of our user authentication logic. This service handles verifying user credentials, managing login sessions, and other user-related operations, acting as the backbone for authentication. On the controller side, we have controllers/account controller, CS, responsible for managing user authentication processes, like login and logout. It interacts with the user service to authenticate users and manage their sessions. Additionally, controllers/projects controller, CS, handles CRUD operations for the projects table. This controller enables creating, reading, updating, and deleting project data, tying directly into the project model we discussed earlier. Finally, there's controllers/home controller, CS, which serves the home or index page when the application starts. It acts as the entry point for users, guiding them into the application's main interface. Overall, these components form the core of our application's architecture. They work together to manage data, facilitate user interactions, and ensure a smooth user experience, aligning perfectly with our theme of building scalable, maintainable software. Let's take a closer look at the key classes involved in managing user identities within our application. First, we have the identity/application user, CS, which extends the built-in identity user class. This means it acts as our custom model for storing user information, allowing us to add any additional properties we might need. Next, the identity/application role, CS, extends identity role and serves as our model for user roles, helping us define different levels of access or permissions. Moving on, the identity/application user store, CS, extends the user store class. This class is responsible for providing the methods that actually handle storing and retrieving user data from our data source. Similarly, the identity/application role store, CS, extends role store and manages the storage of user roles. Now, to manipulate user data effectively, we have the identity/application user manager, CS, which extends user manager. This class offers various methods for creating, updating, and managing users. Correspondingly, the identity/application role manager, CS, extends role manager, giving us the tools to handle roles dynamically. Finally, for the login process, we rely on the identity/application sign-in manager, CS, which extends sign-in manager. This class manages user sign-in workflows, ensuring authentication is handled smoothly. Overall, these classes form the backbone of our identity management system, enabling us to customize and extend user and role handling to fit the specific needs of our application. All right, let's walk through some key components of our application setup. First up, we have the identity/application DB context, CS file. Think of this as the backbone for our database interactions. It extends the identity DB context class, which means it inherits all the features needed for managing user identities. But beyond that, it also includes DB set properties for all the tables we want to work with. This setup makes it straightforward to query and update our database seamlessly. Next, there's the views/home/index, CSHTML file. This is our startup view, the first thing users see when they visit our app. It's where we present the main interface, and it plays a crucial role in user experience. It's important to understand how this view connects to our backend logic and displays dynamic content. Then we have the app settings, JSON file. This is essentially our configuration hub. It holds critical settings like connection strings, secret keys, and other app-specific configs. Keeping these settings in a separate JSON file helps us manage environment-specific configurations easily and keeps sensitive data out of our main codebase. Finally, we look at Startup, CS. This is a vital part of the application lifecycle. It contains the configure services method, where we register all our services and dependencies. Think of it as setting up the foundation for our app's functionality. Then there's the configure method, which defines how the app responds to HTTP requests. Together, these methods ensure our application is properly configured and ready to run smoothly. Connecting these points to our overall theme, each component plays a distinct role in building a robust, scalable application. The DB context manages data, the views handle user interactions, configuration files keep our settings organized, and startup. CS wires everything together. Understanding how they fit together is key to mastering application development. Let's start by understanding what an RFC is. RFC stands for Request for Comments, and it is a formal document released by the IEFT, the Internet Engineering Task Force. These documents are crucial because they define and standardize Internet protocols and technologies. In essence, the IEFT is responsible for releasing Internet standards that ensure interoperability and security across the web. Now, moving on to JSON Web Tokens, or JWTs. A JWT is a JSON object, which is a lightweight, easy-to-read data format. It's specifically defined in RFC 7519, and its purpose is to provide a secure way to represent a set of information between two parties. Think of it as a digital passport or a token that safely carries data, ensuring it can be trusted and verified. So, what exactly is a JSON Web Token? It's a compact, URL-safe token that encapsulates claims. These are pieces of information like user details or permissions. Because it's standardized in RFC 7519, developers can rely on its structure and security features. This makes JWTs especially useful in modern web applications, where secure, stateless authentication and data exchange are essential. Connecting this to our overall theme, understanding RFCs and JWTs helps us grasp how standards and security protocols work together to create a trustworthy and efficient internet environment. It's all about making sure our data remains safe while being easily exchanged across different systems. Let's take a closer look at how JSON Web Tokens, or JWTs, work in the context of authentication. When a user logs in by providing their user ID and password, the authentication server verifies their credentials. Once verified, it creates a JWT, which is essentially an encrypted token, and sends it back to the client. This token acts as proof that the user is authenticated. Now, for any subsequent API requests, the client includes this JWT in the request header. The API server then checks the token to verify the user's identity before processing the request. A crucial point here is that the JWT contains a signature, which is generated based on the header and payload. This signature allows the server to confirm that the token hasn't been tampered with, so the data is trustworthy. Overall, JWTs streamline the authentication process by enabling stateless, secure communication between the client and server. This approach is especially useful in modern web applications where maintaining session state can be cumbersome. Let's take a closer look at the contents of a JWT web token. As you can see, a JWT is made up of several key parts that work together to securely transmit information. First, there's the header, which typically specifies the type of token, usually JWT, and the signing algorithm used. This is important because it tells us how to verify the token's authenticity. Next, we have the payload, which contains the claims. These claims are essentially statements about an entity, like the user, and can include things like user ID, roles, or permissions. This is the core data that the token carries. Finally, there's the signature, which is created by encoding the header and payload, then signing them with a secret key or private key. This signature ensures the token hasn't been tampered with. Understanding these parts is crucial because it helps us see how JWTs enable secure and efficient data exchange in modern web applications. This structure allows for both secure verification and easy access to user information, aligning perfectly with our goal of creating scalable and secure authentication systems. Let's take a closer look at this sample JWT token, which appears as a long string of characters. This is a typical example of how JWTs are structured. The first part is the header, which specifies the type of token and the signing algorithm used. The second part is the payload, containing the claims or user information, like user ID and name. The third part is the signature, created by hashing the header and payload with a secret key, ensuring the token's integrity and authenticity. Now, moving to the key points on this slide, we see the hashing algorithms listed here, such as HMAC with SHA-256, RSASSA with SHA-256, and ECDSA with SHA-256. These are common cryptographic techniques used to secure JWTs. The table illustrates how the header, payload, and secret key come together to generate a token. The process involves encoding the header and payload into base 64, then hashing the combined data with a secret key, and finally encoding that hash into base 64 to produce the signature. This signature verifies that the token was issued by a trusted source and hasn't been tampered with. Understanding this process is crucial because it underpins the security of token-based authentication systems. When you generate a JWT, you're essentially creating a secure, compact package of user information that can be verified without exposing sensitive data. It ties back to our overall theme of secure communication and data integrity in modern web applications. Now, let's walk through how the verification algorithm works. First, we combine the received header and payload by concatenating them with a dot in between. This creates a single data string that represents the original message. Next, we hash this data using a secret key, producing a hashed version of the data. This hash acts as a unique fingerprint, ensuring data integrity. Then, we encode this hashed data into a base 64 string, which becomes our signature for verification. To verify the signature, we compare the signature we just generated with the signature received alongside the message. If they match, it confirms that the message hasn't been tampered with and is authentic. It's important to note that the received signature, as well as the header and payload, are all transmitted as base 64 strings, which helps ensure safe and consistent data transmission. The key point here is that this process ensures the integrity and authenticity of the message by verifying that the data hasn't changed since it was signed. This verification process is crucial when handling JWTs and subsequent requests, as it guarantees we're working with trusted data. When working with JWTs, it's important to avoid including sensitive user information in the payload, such as passwords or PINs. Instead, using identifiers like user ID and timestamps is recommended because they provide necessary context without exposing sensitive data. Also, keep in mind that the payload should not be overly large, as a bigger payload increases the size of the JWT token, which can impact performance. Remember, JWTs are only signed and encoded, not encrypted. This means that while their integrity can be verified, the data within them remains visible to anyone who has access to the token. Therefore, JWTs do not guarantee security for sensitive information unless additional measures are taken. If you need to protect the data further, you can encrypt the header and payload before applying the JWT algorithm. This adds an extra layer of security, ensuring that even if someone intercepts the token, they cannot read the sensitive contents. Always enable HTTPS when using JWTs. HTTPS provides end-to-end encryption, safeguarding the token from being intercepted during transmission. This is a critical best practice to prevent man-in-the-middle attacks. Avoid storing JWT tokens in cookies whenever possible, as cookies can be accessible to attackers, especially if they are not properly secured. Instead, consider other storage options like local storage, but always evaluate the security implications. By following these best practices, you can significantly enhance the security and efficiency of your JWT authentication process, making your application more robust and trustworthy. Today, I want to introduce you to the concept of HTTP interceptors. These are powerful tools within our Angular applications that help us intercept and modify HTTP requests and responses. Think of them as middleware for your HTTP calls, kind of like gatekeepers that can add headers, handle errors, or even log activity before the request reaches the server or after the response comes back. One of the key points is that interceptors are very flexible and can be chained. This means you can have multiple interceptors working together to handle different concerns, like authentication, error handling, or caching, without cluttering your core logic. Another important aspect is that interceptors implement a specific interface, which makes it easy to integrate them seamlessly into Angular's HTTP pipeline. They're especially useful for cross-cutting concerns that affect many parts of your app, because they centralize these behaviors in one place. Connecting this to the overall theme of building scalable, maintainable applications, interceptors help us keep our code clean and consistent. Instead of repeating the same logic everywhere, we handle common tasks globally through interceptors. That's why understanding how to effectively use them is so important for creating robust applications.